Good morning, Kim 151. I did want to start with you today on the information in chapter 6. In chapters 1 and 2, we covered about the atom, but if you remember, we talked primarily about the nucleus of the atom and the protons and the neutrons. Well, when we go to chapter 6, that's when we focus more specifically on the electrons in the atom. One of the very first things that is pointed out in chapter 6 is that your electrons can behave as both waves and particles. And because they can behave as both waves and particles, the waves can be a part of the electromagnetic spectrum. If you can see the waves as color, then we're talking about the visible part of the electromagnetic spectrum, and that you need to be familiar with the different parts of electromagnetic waves. Please remember, when we talk about waves, we're talking about an oscillating, repeating thing. So we're generally talking about waves, and it's like the waves you talked about in math class, where you've got a top and a bottom, a top and a bottom, a top and a bottom. This is what we're referring to when we refer to waves. Remember, the top of your wave is called the crest of the wave. The bottom of the wave is called the trough of the wave. The distance from one point on a wave to the same point on a different wave is known as your wavelength. And how many waves pass a given point in a certain amount of time, that's known as your frequency. That becomes majorly important because we notice that there's a relationship between the wavelength and the frequency of waves. So you need to be familiar with that, and that relationship we represent as C equals lambda nu, where lambda equals your wavelength. And remember, your wavelength should be given in the units of meters. And the nu represents your frequency. And the units for frequency are seconds to the -1, or 1 over s, or hertz. And so if you're given values, like if I give you the wavelength, you should be able to find the frequency, or if I give you the frequency, you should be able to find the wavelength. And that is because in that expression, C is a constant. In that expression, C is a constant. So C equals lambda nu. The value that your textbook uses for C is 2.998 times 10 to the 8th meters per second. And so again, remember, your wavelength has to be given in meters. Your frequency has to be given in per seconds or hertz. If it's not given in meters or per seconds or hertz, you have to do a conversion before you can solve any of the problems there. So again, if I give you a wavelength and it's not given with the units of meters, you have to do a conversion to solve that problem. Now, most of these wavelengths will be given in scientific notation, so you really need to be aware of how to enter scientific notation in on your calculator. If you have a question about how to do that, please reach out to me and let me know. But again, if I give you wavelength or frequency, you should be able to find the other one. The next thing that's talked about in your book is the photoelectric effect, which was discovered by Einstein in 1905. And what he figured out is that with the photoelectric effect, the amount of particles that are ejected from the surface of a shiny material is actually related to how much energy the light that you shine on the metal has. And so the formula to solve those kinds of problems is E equals H nu. E standing for energy, H standing for Planck's constant, and nu again standing for frequency. Again, the units for frequency have to be hertz. The value of H is a constant. It's actually 6.626 times 10 to the -34, and the units are joules times seconds. And so you will have to, again, know how to do conversions with that kind of problem. What happens if I give you frequency and I ask you to find energy, or if I give you energy and ask you to find frequency, how would you do that? Or if I gave you wavelength and ask you to find energy, how would you do that? And so just remember, if I give you wavelength, you've got to convert the wavelength to frequency. And then once you have the frequency, you would plug it in to find the energy if that's what you were looking for. So please be prepared to do that, because you'll have to do that on your homework. One of the next things that's talked about in chapter 6 is your line spectra, because what we find with electrons is that electrons are found in the electron cloud of the atom, and they are found at generally discrete distances away from the nucleus. So they're basically found on energy levels. Now, when electrons are at the ground state, they're at the lowest energy level. However, if I excite them, and I can excite them by having them absorb energy, so anything I do that makes them absorb energy, that will let them go to the excited state. And I always explain the excited state like, think about what would happen if you were babysitting and you gave the kids you were babysitting a bunch of candy. You know how hyper children get? Well, that's kind of the same thing that electrons do. They get very hyper and they have a lot of energy and they're just bouncing around all over the place. Well, eventually they come down from that high and they crash. So they fall back down to their normal energy state. But when they do that, they give off energy. If we see that energy as lines of color, then we have an emission spectra. And so that emission spectra we can use to actually figure out what energy was given off, what wavelength, what frequency was given off from those electrons as they were falling. Now, the next thing that we need to talk about as it relates to electrons is the Heisenberg uncertainty principle. And your book goes into a whole lot of technical detail about this. The one thing that I do need you to know about Heisenberg's uncertainty principle is that it says that you cannot know two pieces of information about the electron accurately at the same time. You can know the position or you can know the speed. You cannot know both of them at the same time accurately, okay? So I can either know where the electron is or I can know how fast it's going, but I can't know both where it is and how fast it's going at the same time. The next thing that's talked about in your book is your quantum numbers. And if you'll think of quantum numbers as GPS coordinates, just like with GPS, you're given a latitude and a longitude. Quantum numbers are actually a specific location for a specific electron. And so there are four basic quantum numbers that you need to be familiar with. The first quantum number is your principal quantum number, and it basically tells you what energy level the electron is located on. For elements, if you want to know the position of the highest energy electron, the principal quantum number of that highest energy electron is always going to be the highest row number. That's the principal quantum number for your highest energy electron. Whatever your row number is, that would be your quantum number for that particular electron. The next quantum number that you would give is the angular momentum quantum number. And what that does is describe what kind of sub-level it's in. So row number is your energy level. The sub-level is what kind of or what shape orbital a particular electron is located in. And what we find on the periodic table is that the periodic table has kind of been divided out into sub-levels for us. Our columns 1 and 2 actually represent our S sublevel. Our columns 13 through 18 represent our P sublevel. Our columns 3 through 12 represent our D sublevel. And then element or any electron that's located in an F sublevel is going to be one that's in the rows that are down at the bottom of the periodic table. All right, so again, sublevel depends on where the element is located on the periodic table. The third quantum number is our orbital quantum number, or our magnetic quantum number. It tells us what particular orbital our electron is located in. So we know if we're an S, there's only one orbital possible if you're an S. If you're a P, though, there are 3 orbitals possible. So your magnetic quantum number will tell you which of those 3 orbitals you're located in. If you're a D sublevel, then your magnetic quantum number would be one of 5 things, because there are 5 d orbitals, or 5 d orbitals if I'm in the D block. All right, and so again, that magnetic quantum number would tell me which of these 5 orbitals I'm located in. And then the 4th quantum number is my spin quantum number, which tells me which one of the electrons I am. Because what we know is that one orbital can only hold 2 electrons. One orbital can only hold 2 electrons, but the 2 electrons that it holds must be doing different things. So we say that one electron is spinning clockwise and the other electron is spinning counterclockwise. And so we represent that spin quantum number with either +0.5 or -0.5. One for going one direction and the other for going the other direction. Now, when we go back to our sublevels, whatever kind of sublevel I am, my S, my P, my D, or my F, that will determine what the shape of the atom actually is, okay? And again, that shape is accomplished by placing these orbitals on top of one another. So if I'm an S, I'm always shaped like a sphere. When I'm a P orbital, though, I'm shaped like a dumbbell. When I'm a D orbital, I'm shaped like a 4-leaf clover. And when I'm an F orbital, I'm shaped like a 6-lobe clover. And so again, the actual shape of the atom is actually determined by the sublevels that are present. All right, and again, what are these orbitals? These orbitals represent locations where there is a 90% chance of finding an electron, a 90% probability of finding an electron. Just like each of you all have homes, if I were to come to your house at any time, that doesn't mean that you'll always be home whatever time I were to come to your house. And the same thing is true of electrons. Electrons can go anywhere within the atom they need to go. And so, again, I can know either where it is or how fast it's going. I cannot know both things. Now, because no more than 2 electrons can live in an orbital, that the principle that tells us that is the Pauli exclusion principle, which says that no electrons in an atom can have the same 4 quantum numbers. Okay, and so when we start talking about the energy of our sublevels, well, you know that your energy level, the lower your energy level is, the lower amount of energy it has. So energy level 1 has a low amount of energy compared to an energy level 7, which has a large amount of energy. When I start talking about my orbitals or my sublevels, when you look at the S sublevel is always going to be the lowest energy sublevel. Your P sublevel is a little more energy than the S. Your D is a little more energy than the P, and your F is a little more energy than the D. All right, and so what you see actually as you look across the periodic table, you see the order that the electrons start to arrange themselves. So on row 1, you know there's only one sublevel possible, and that's your S, and so we would call that the 1s. So all the elements on row 1, their electrons, are located in the S orbitals. When I move to row 2, though, there are actually 2 sublevels that are possible. That's your S and your P. So your elements that are in column 1 or 2, their electrons are going to be in the S. Your elements that are in columns 13 through 18, those are going to be in your P. And so you'll notice your S has a maximum number of electrons of 2 because there's only one orbital there. Your P has a maximum number of electrons of 6 because there are 3 orbitals there. When we move to our D block, our D has a maximum number of 10 electrons because there are 5 orbitals, and our F has a maximum of 14 electrons because there are 7 orbitals. However, when you get to row 3, you will notice row 3 should have 3 sublevels. But if you look at the periodic table, you only see 2. You see the ones in the S from column 1 and 2. You see the ones in the P from columns 13 to 18. But where is your third sublevel, your D? And the answer to that question is the D block electrons are actually located on the row below. So when you go down to row 4, you'll notice you've got column 1 and 2, which represent your S. So because it's on row 4, that would be your 4s, but the element that's right beside of your 4s electrons actually is your 3d. So when you start column 3 and you're going from column 3 to column 12, that's actually your D block. So every time you give me a D block letter, you have to go down 1 from your row number to have the correct D block. And when you give me an F block letter, you actually have to go down 2 from the row number to have the correct F block. Okay, and so remember, the top row of the bottom 2 rows actually belongs on row 6, and so that would be the 4F, and the bottom row belongs on row 7, so that would be your 5S, F. So when you get ready to write your electron configurations, please make sure that you can follow in order from the elements that are given on the periodic table. Now, if you have trouble traveling from left to right across the periodic table to write out your electron configurations, you can use off-ball principle, and all you do is draw out a diagram that shows which orbitals each energy level has, and then you put the arrows in and you follow the arrow from the tail of the arrow to the head to know where to go next. And you can memorize that organization if you need to. Now, your book has a really good diagram that shows you the blocks of the periodic table, but what we're going to talk about in the next video is how to write your electron configurations. So please come back and join us for how to write electron configurations. If you've got any questions on anything I've covered, please reach out to me, and please make sure you're getting your homework done. Don't procrastinate. Get a little bit done every day. Reach out if you've got any questions. I hope you have a good rest of your day.